Welcome to MRL. In this learning session, we'll be learning squares and the properties of squares, which is a chapter of Ganith Prakash, a textbook of 8th NCERT CBSE textbook. Now let us begin the basics with learning the basics and then understand as to what is a square and their properties. Now before we begin with the subject main, let us understand what are the factors of a number. Now if you take 2 has factors 1 and 2 because 2 is divisible by 1, 2 is also divisible by 2, therefore the factors of 2 are 1 and 2. Factors of 4 are 1 to 4 because 1 divides 4 completely, 2 divides 4 completely, 4 divides 4 completely, and therefore 1 to 4 are the factors of 4. So also 1, 2, 4, 8 are the factors of 8 because 8 is divided by 1, 2, 4, 8 completely. And 9, the factors of 9 are 1, 3, 9 because 1 divides 9 completely, 3 divides 9 completely, and 9 also divides 9 completely, and therefore the factors of 9 are 1, 3, 9. So therefore the numbers that divide a number completely are known as factors of the number. So that is the definition. The numbers that divide a number completely are known as factors of the number. So these are factors because they divide these numbers completely. Now the next point of discussion is prime numbers. Now the factors of 2 are 1 and 2, factors of 3 are 1 and 3, factors of 5 are 1 and 5, factors of 7 are 1 and 7. That means each of these numbers have only 2 factors. Therefore, the numbers that have only 2 factors or the numbers that are divisible by 1 or itself are known as prime numbers. Please remember that. Number of factors. 1 has 1 factor, 4 has 3 factors, 6 has 4 factors very clearly, 9 has 3 factors. That means 1 is having 1 factor means odd number of factors, 3 is again odd number, 4 is even number, and 9 is having 3 factors, again an odd number of factors, counting them 1, 2, 3, 1, 2, 3. That means the numbers have odd number of factors or even number of factors. That means the numbers can have odd number of factors or even number of factors. But very interesting thing is, if you look at 4 is having factors 1 to 4, 9 is having factors 1, 3, 9, and 4 is said to be a square number. Why it is, we'll learn very soon. And 9 is also a square number. Why it is, we'll learn very soon. Therefore the squares have odd number of factors. 4 is having odd number of factors, 3 factors, 9 is also having 3 factors. So generally the squares have odd number of factors. Now remember that. Now coming to as to what is a square number. A number which can be expressed as a product of 2 equal factors are known as perfect squares. For example, 25 can be expressed as a product of 5 into 5. 81 can be expressed as a product of 9 into 9. That means 25 can be expressed as a product of 2 factors, equal factors, and 81 also can be expressed as a product of 2 equal factors, and therefore 25 and 81 are perfect square. So if you have a integer, if a is an integer, and b is equal to a into a, that means b can be expressed as a product of 2 equal factors, then b is a perfect square. B is a perfect square. So please remember that. Now how to represent a square number? Now if you have it is generally represented as n square, where n is any integer. So n is any integer, it is said as n square. So for example, 25 is 5 square, 81 is 9 square. So the n square of n is n square, where n is any integer. Now it is read as n to the power of 2. How to read this? N to the power of 2 or n squared or n square or second power of n. So that is how we read them. For example, 2 into 2 is 2 square, 2 squared or 2 to the power of 2. So we read it as 2 squared or 2 to the power of 2. Now remember, n square is a perfect square because it is a power of 2. N square is always positive because when we multiply 2 positive factors, it is again 2 into 2 is 4, minus 2 into minus 2 is also 4 because minus into minus it becomes plus, and 0 is also a perfect square. A natural number n between m square and m plus 1 square cannot be a perfect square. For example, if you take the 2 perfect square 1 and 4, 1 square is 1, 2 square is 4, between 1 and 4 we have 2 and 3, 2 and 3 are not perfect squares. Remember that. Now coming to the squares of even numbers, the square of 2 square is 4, square of 4 square is 16, which both are even. Therefore the squares of even numbers are even. Squares of odd numbers, 3 is an odd number, 3 square is 9, 9 is odd number, 5 square, 5 is odd number, 5 square is 25, again an odd number. The squares of odd numbers are odd. Now digit in the units place of perfect square numbers. If you take the numbers 1 to 10 and square them. We have got 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on. 10 square is 100. Now check the digits in the units place. The digits in the units place are 1, 4, 9, 6, 5, 6, 9, 4, 1, 0, and if I list them, there is 0 in the units place, there is 1 in the units place, there is 4 in the units place, there is 5 in the units place, there is 6 in the units place, and there is 9 in the units place. Therefore, the digits in the units place in a perfect square number are 0, 1, 4, 5, 6, 9. Remember that. But if a number ends in any one of the 0, 1, 4, 5, 6, 9, it is not that it is 100% a square number. It may be or may not be a perfect square. For example, 25 is equal to 5 square is a perfect square because it's a perfect square because there is a digit 5 here, because 5 is there means it's a perfect square, but 35 is not a perfect square. Therefore, the presence of 0, 1, 4, 5, 6, 9 as digits in the units place does not give us a perfect square. It may be or may not be a perfect square. Remember that. Now the digits which are there in the units place of non-perfect squares. The numbers with units place of digits 2, 3, 7, 8 are non-perfect squares. It is a sufficient condition. It means that if there is a digit 2, 3, 7, 8 or 8 in the units place of any number, it is 100% a non-perfect square. So therefore we say it is a sufficient condition. The number of n zeros in a square number. If I take 10 square, it is 100, 20 square is 400, 100 square is 10,000. So if there is 1 zero, there are 2 zeros in the square number. If there is 1 zero, 2 zeros in the square number. If there are 2 zeros, then there are 4 zeros in the square number. That means if there are k zeros in a number, then there will be 2 k zeros in the square number. So if a number, and again if you observe here, the zeros are even. 2 zeros even, 2 zeros even, 4 zeros also an even number. Therefore, if a number has odd end zeros, then it is not a perfect square. There have to be even end zeros here. Remember that. Therefore, I have written here the number of n zeros are even, and if k are the zeros in a number, then 2k will be the number of zeros in its square number. Now, remainder of a square when divided by 3 or 4. So supposing we have a number 4 which is a square number. If I divide it by 3, then 3 1 is 3, remainder is 1. If I take a 9 which is a perfect square, divide by 3, 3 3 is a 9, remainder is 0. If I divide 16 which is a perfect square by 3, 3 5 is a 15, remainder is 1. And in each case we find the remainders are either 1 or 0. Okay, remember that. So therefore any square number divided by 3, the remainder will be 1 or 0. Now let us take the square number division by 4. If I divide a perfect square 4 by 4, I get 0 as the remainder. 9 divided by 4, I get 1 as the remainder. And 16 by 4, I get 0 as the remainder. And that means again, when a square number is divided by 4, the remainders are either 0 or 1. Therefore, the remainders are 0 or 1 when a perfect square is divided by 3 or 4. Remember that, a very important property. Now product of 4 consecutive integers plus 1 is a perfect square. Now what does that mean? Supposing we have, let us take the 4 consecutive numbers, 1, 2, 3, 4 are 4 consecutive numbers, take the product of them, add 1 to it, that means it becomes 24 plus 1, 4 3 is 12, 12 is 24 plus 1, 24 plus 1 is 25 and 5 square. So therefore the product of 4 consecutive numbers plus 1 is a perfect square. Let us take one more example. 2, 3, 4, 5 are consecutive numbers. Multiply them, add 1, you get 120 plus 1, 121 is 11 square. A very important property again. So multiple, that means multiplying 4 consecutive numbers and adding 1 to that product, we get a perfect square. Now sum of odd natural numbers. Let us take the first odd number 1. 1 is equal to 1 and 1 is 1 square. If you take the first two odd numbers, 1 plus 3 is 4, it is 2 square, that is, it is again a perfect square. If you take 3 odd numbers, first 3 odd numbers starting from 1 again, it is 9, which is a perfect square, that is 3 square. And take the first 4 odd numbers, add, we get 16, and it is 4 square, which is again a perfect square. Therefore, the sum of odd numbers starting from 1 will give us perfect square. If you add 1 odd number, we get 1 square, 2 odd numbers, 2 square, 3 odd numbers, 3 square, 4 odd numbers, 4 square, 5 odd numbers, 5 square, 6 odd numbers, 6 square, n odd numbers, then n square. So adding n odd numbers starting from 1, we get a perfect square, that is n square. Supposing if you add 15 odd numbers, then we get 15 square, that is 225. A very interesting relation or formula to find out the sum of odd numbers. Supposing if you are asked to find the sum of first 25 odd numbers, it is 25 square, that is 625. Remember that. Now how to find the squares of any given number? There are different methods of finding. We have got the product method, the column method, the diagonal method, and the identity method. So let us understand these methods one by one. Now let us go to the product method. Product method is very easy. If you are asked to find out 25 square, just multiply 25 into 25, you will get 625. That means you have to multiply the number 2 times. That is 25 into 25 because it is a square number. Now the second method is the column method. In the column method, if you are asked to find out a square number, 25 of square, then take 2 as A and 5 as B. Take A as 2 and B as 5. Make 3 columns, write A square, 2AB and B square. In the B square column, write 5 square, that is B square is nothing but 5 square. 2AB will be 2 into A into 5, that is 2 into 2 into 5, and A square will be 2 square because A is 2 square here. Now square of 5 square is 25, and 2 into 2 into 5 is 20, 2 square is 4. When you have 25 here, write 5 down, take 2 as a carry. Now add to that 20, we get 22, bring 2 down, carry this 2 to the next column, we get 4 plus 2, that is 6. So therefore, then bring 6 down, so therefore the square of 25 is 625, and the same answer we get. Now in the diagonal method, make a square, and write 2 and 5 and 2 and 5 in the vertical column and the horizontal column. Multiply 2 into 2 is 0.4, 2 into 5 is 10, 5 into 2 is 10, and 5 is 25. Now add diagonally. Add the first diagonal, it is 5. Add the second diagonal, 0 plus 2 plus 0 is 2. Add the third diagonal, 1 plus 4 plus 1 is 6. And the fourth diagonal, 2, that is 0 and 0 down. Therefore we get the number 625. Again the square of 25 is 625, which we have got again the same answer. Now the fourth method is, again I have taken 25 square here. Now you have to use an identity. The identity is A plus B whole raised to square, which you have learnt in algebra. That is A square plus 2AB plus B square. Here A is 20 and B is 5. A is 20, B is 5. Now wherever A is there, B is there, substitute them. We get A square is 20 square plus 2 into 20 into 5. B square is 5 square. 20 square is 400, and 2 into 20, 40 into 5, 200. 5 square is 25. Add, we get 625. So generally we use the product method, the column method and diagonal method are rarely used, but definitely identity method is also a very convenient method to find the squares of numbers. Now coming to the squares of fractions. When you are given a fraction 2 by 3, then the square of that will be 2 by 3 whole raised to square. That is multiplying 2 by 3 twice, we get 2 by 3 into 2 by 3 is 4 by 9. Or else we can even apply the the laws of exponents here. 5 by 7 square can be written as 5 square by 7 square, that is 5 into 5, 7 into 7, that is 25 by 49, because A by B whole raised to square is equal to A square by B square, we know that. And minus 7 by 11 square will be minus 7 by 11 into minus 7 by 11, minus into minus is plus, 7 7 is 49 and 121. So please remember these examples. Now coming to the squares of decimals, 0.5 square will be simple, forget the decimal. 5 square will be 25. A number of decimal places will be 2 places. So 5, there are 2 places. Just put the decimal point after 2 places. The answer is 0.25. Or else multiply 0.5, 0.5. Then next one is minus of 0.02 square, but natural minus square will be plus, and 2 square is 4. Now after 4 places put the decimal point, 1, 2, 3, 4 decimal point. So that is the answer for 0.02 square. Now if you want to find out the square of 0.03 upon 0.2 whole raised to square, first of all eliminate the decimal in the denominator, and therefore I multiply by 10 here in the numerator and the denominator. I get 0.3, because 0.03 into 10 is 0.3, 0.2 into 10 is 2. Now square of that will be 0.3 into 0.3, and 2 square will be 4. So it will be 0.09 divided by 4. The answer is 0.0225. So that is how we find out the squares of fractions. Now coming to the next one, that is the parity of a number and its square. If you take 5 square, there is 1 digit here, the square number has 1 pair. Always remember, if there is 1 digit, there will be 1 pair in the square number. If there are 2 digits, there will be 2 pairs. Taking 1 digit also is the pair, but the pairing should be done from right to left. So first pair and then the second pair. If it is of 3 digits, then there will be 3 pairs, 1 pair, 2 pair and 3 pair. Always pairing should be from right to left. So 1 digit, there will be 1 pair in its square. 2 digits, there will be 2 pairs in its square. 3 digits, there will be 3 pairs in its Now this is the interesting point. We have to find the nth odd number and also find the consecutive square of the number. Now how to do that? Let us understand. Nth odd number is found out by the relation 2n minus 1, where n is equal to 1, 2, 3 and so on. For example, if we want to find the fourth odd number, then 2n minus 1 will be 2 into 4 minus 1, 8 minus 1 is equal to 7. So fourth odd number is definitely 7. So therefore this relation is a very important relation. We can find out the odd number, whatever the odd number you want, you can find out this by this relation. For example, if you want to find 25th odd number, then 2 into 25, 50 minus 1, 40. So like that we can find out any required odd number using 2n minus 1. Now here we are given 35 square, that is 1225. Now you have been asked to find out 36 square. Now to find out 36 square, you just add the 36th odd number to 1225. We have to just find the 36th odd number and add to 1225. Please understand this. We are given the 35th square. 35 square is 1225. To find we have been asked to find out 36 square, and to find the 36 square, just find out the 36th odd number and add to 1225. So the 36th odd number will be 2 into 36 minus 1. Using this formula, we get the odd number 36 odd number as 71. Now add this 71 to 1225. You will get 1296. Therefore 1296 is 36 square. So the method is, if you are given any square of any odd number, then find out the next odd number by just using the formula 2n minus 1, and then add to that 35. We will get the number that is the square of the next number, that is the consecutive square. Now to find 37 square, for example, then find out the 37th odd number. Please understand, find out the 37th odd number and add to 1296. Supposing if you want 38 square, then find out the 38th odd number and then add to 37 square. So that is how the things go on. So please remember, a very simple method but very interesting method of solving. Now coming to the number of non-perfect squares between two consecutive squares. Now let us understand what is the meaning of this. We have a square number here, 2 square, 4, 3 square is 9. Between 4 and 9 we have got non-perfect square, that is 5, 6, 7, 8. There are 4 of non-perfect squares are there between 4 and 9. Let us take one more example. We have 4 square and 5 square. 4 square is 16, 5 square is 25. In between 16 and 25 we have got 17, 18, 19, 20, 21, 22, 23, 24, 22, and this is 23, not 33, 23 and 24. So these are non-perfect square numbers, and these how many are there total? 8. So between 4 and 9 there are 4 non-perfect squares. Between 16 and 25 we have got 8 non-perfect squares. Now to find that, the method is very simple. Take 4. Take this 4 and then not 4, take 2 and multiply by 2. 2 into 2 becomes 4. Take 4, multiply by 2, you will get 8. So that is the method. So for example, if the perfect square is n square and the next perfect square will be n plus 1 whole to square, then take n, multiply by 2, there will be 2n non-perfect square numbers. So therefore the conclusion is, between n square and n plus 1 whole to square, the number of non-perfect squares will be equal to 2n. So it is 2 into 2 is 4. 4 into 2 is 8. If that is 5 square and 6 square, then 5 into 2 is 10, and like that. So that is what is the method of finding out the number of non-perfect squares between two consecutive perfect square numbers. Now triangular numbers. Now if we have the dots, dot is 1, dots are 3, we can arrange them in a manner that we get triangles, and therefore they are called as triangular numbers. So 1, 3, 6, 10, they form triangles and they are called as triangular numbers. Now to find any triangle, that is triangular number, that is nth triangular number, the formula is n plus 1 upon 2. For example, if you want to find out the fifth triangular number, then it will be 5 in the bracket 5 plus 1, that is divided by 2, that will be 5 into 6 divided by 2, that is 15. Therefore 15 is the fifth triangular number. So this formula can be used to find out the required. So we can find out the required triangular number using this relation, triangle n is equal to n plus 1 upon 2. Please remember that. Now coming to this a very important property of triangular numbers, when we add two consecutive triangular numbers, then it is a perfect square. Now triangular number 1 is 1, triangular number 2 is 3. When we add triangular number 1 and triangular number 2, we get 1 plus 3, that is 4, it is a perfect square, 2 square. Similarly, take triangular number 2, that is 3, and triangular number 3, and that is 6. Add them, we get 9, which is a perfect square. So therefore, sum of consecutive triangular numbers is 100% a perfect square, a very important property of triangular numbers. Now to check if a given number is a perfect square, it is a very simple method. There are two different methods, that is factors method and subtraction method. In factors method, what we have to do is write the prime factors of the given number 81. If you want to check whether 81 is a perfect square or not, write the prime factors of 81. That means 3 27s are 3, 9s are 3, 3s are 3, 1. So we have got 4 factors here, 3 into 3 into 3 into 3. They are in pairs. Because the factors are in pairs, 81 is 100% a perfect square. So please remember, to confirm whether a given number is a perfect square or not, find the prime factors of that number, pair them. If the factors are in pairs, then that number is a perfect square, and that is the factors method. Now coming to the subtraction method, we know that the sum of odd numbers is a perfect square. So we have to find out how many odd numbers have to be subtracted to get to know whether that is a perfect square or not. If it is a perfect square, then ultimately the remainder comes 0. When you keep on subtracting, the final answer will be 0. Let us understand this. Supposing if you want to check whether 49 is a perfect square or not, subtract the first odd number, we get 48. Subtract the next odd number from 48, we get 45. Subtract 5 from 45, we get 40. Subtract 7 from 40, we get 33. Subtract 9 from 33, we get 24. Subtract 11 from 24, we get 13. And 13 minus 13 is 0. Ultimately we get the subtraction. When we go down the subtraction, we get 0. We have gone 7 steps down. Rather, we have subtracted 7 times, and therefore the 49 is 100% square of 7. Therefore 49 is a perfect square. So please remember that. So therefore, when odd numbers are subtracted from any given number, and if we get 0 at the end after the steps of subtraction gives us 0, then 100% it is a perfect square number. Remember that. Now coming to the next and very important point, that is to check if a given number is a perfect square. Again, the same example. That is how to check it. A slightly bigger number I have taken. Now if take 1296, write the factors of prime factors of 1296, we get 2 into 2 into 2 into 2 into 3 into 3. That means there are 4 2s and 4 3s. That means they are all in pairs. Because they are all in pairs, 100% 1296 is a perfect square, and it is 36 square. Therefore remember, to find out the given number is a perfect square or not, just write the factors and pair them. If they are in pairs, 100% it is a perfect square. Now to find the least number to be multiplied or divided to make a number a perfect square. Now we are given a number 9408. First of all, find the prime factors of this and check and write them. And when we find the prime factors of 9408, we get 2 into 2, 2 into 2, 2 into 2 into 3 into 7 into 7. We have 1, 2, 3, 4 pairs here, but 3 is single. If 3 is single, it is not a pair. That means 9408 is 100% not a perfect square. If it is not a perfect square, then if you have to make it a perfect square, either you multiply it by 3 or divide it by 3. Now I have multiplied by 3 here. I got 28224, and therefore 28224 is a perfect square. Therefore the smallest number by which 9408 has to be multiplied to make it a perfect square is 3, because 3 is single. Now remember that. Now to find the smallest integer with which 336 has to be divided to make it a perfect square. In the earlier example, we had multiplied 3. Now let us see what are the factors of 336. The factors of 336 are 2, 2, 2, 4, 2. That is 4 2s, 3 and 7. So we got pairs are 2 pairs there, 3 and 7 are single. So 3, that means 336 has to be divided by 3 as well as 7, that is 21. So when I divide 336 by 21, I get 16, and therefore you see that 16 is a perfect square, that is 4 square. So therefore, to make 336 a perfect square, we have to divide it by 21, because 3 and 7 are single, and 3 into 7 is 21. So divide 336 by 21, we get a perfect square. So that is the method. Now to find the nearest perfect square to a non-perfect square. This is again a very important method of finding or understanding how to find out whether a given number is square or not, and between, if it is not a square, and in between which two perfect squares it lies. Now 90 lies between two perfect squares, that is the 9 square and 10 square. 81 is 9 square and 100 is 10 square. So 90 lies between 81 and 100. But still it is not clear as to what will be the approximation. So now if you see, 90 minus 81 is 9, and 100 minus 90 is 10. That means this 90 is more near to 81 and than 100, and therefore we can approximately say the square root of 90 is 9 and not 10. Therefore, approximation is the square root of 90 is 9. So it lies much nearer to 81 than 100, and therefore the 90 lies between 81 and 100, all right, but approximately the square root of 90 is 9. So that is how that is what is the study of the squares and its properties. Try to understand them, okay, one by one, step by step, learn them and practice them, and note down all these properties in a book and revise them and keep it as for your future reference. Okay, thank you.